So first question, let's go to the first question. Two forces of 20 Newton act as a couple. They are couple forces. The forces act at a distance of 10 centimeter from the center of the rotation. That means this is the distance from forces to the pivot. Okay. What is the torque produced by the couple? So to do such kind of question, you are just going to multiply force times distance. Okay. Force times distance. 20 times. You have to convert your distance to meter. Why? Because SI unit of torque is Newton meter, so you have to convert the centimeter into meter, which is going to be 0.1 meter. So when you multiply 20 times 0.1, you are going to get 2 Newton per Newton meter as our torque. Okay, this is the first question. The second question is, ladder stands on the ground leaning against a wall. It is safer climbing up the ladder if the ground is frictionless and the wall is rough. The second one, the ground is rough and wall is frictionless. The third one, the ground is frictionless, the wall is frictionless. And the fourth one, the ladder leans at 45 degrees and the ground is frictionless. So the best answer over here, if the ground is frictionless and the wall is rough, what's going to happen? That means the ladder will not the ladder will not move or will not slide while you are climbing. So the best answer for this question will be A. So let's go to number 3. I'm gonna change the screen right now for number 3. For number 3, let's go to use the smartboard properties. So this question, a 5-meter weightless strut hinge to a wall is used to support an 800 Newton block as shown in the figure. Here 800 Newton over here. So it is asking you horizontal and vertical components of the force of the hinge, the strut part. Okay, we're gonna find the horizontal and vertical components of it. So first of all, let's consider that hinge is a pivot. Hinge here is our pivot. Okay, so if this is our pivot, we're gonna have here F horizontal. We're gonna have here F vertical, and we are going to have here normal force. Okay, and here is going to be our theta. All right, so and here look at the rope over here. We are going to have here tension force, and here again it's going to be our normal force. Okay, so our normal force will be downward. Okay, so what we know? We know that here is 3 meter and here is 5 meter. The distance of the strut is 5 meter. So when you apply Pythagoras over here, you're gonna get the height of the wall as 4 meter. Okay. So when you get the height of the wall at 4 meters, so you can now do the questions. First of all, let's find the t. To find the t, we are gonna use here. We're going to multiply t times the height of the wall and the weight times the distance from wall to the here. Okay, they're going to multiply that part to find the t. So it's going to be t times 4 meter equal to 3 meter times 800. Okay, to find the t. So as you see over here, when you simplify them, you're going to find t as 600 Newton. This is t. Why we need t? Because we have to divide the component of the f. We have to find the component of the f. So that's why we need t. So to find the f, what are we gonna do? F equal. Now we know the t, which is 600 Newton, right? It's given you, and we have 800 Newton block over here. So we are gonna just apply Pythagoras over here. 800 square plus 600 square. This is going to give us our F, okay? So when you do this, you're going to get F as 1000 Newton, okay? So now it's easy, 1000 Newton, sorry. Now it's easy to find horizontal and vertical component of the given, okay? To find the horizontal component, we can use like trigonometry over here. To find F times sine theta will give us what? F times sine theta will give us horizontal component. And for y component, for vertical component, we are going to use F times cos theta. Okay. So F times sine theta. F we already found 1000. What is sine theta? How can you find the sine theta? You can just divide 3 over 5, like across the angle over hypotenuse. So it's going to be 3 over 5. You can just write over here, which is going to be 0.6. When you multiply this, you're going to get horizontal component as 600 Newton. Okay, this is going to be horizontal component. So the second one, for the vertical component, again our F is 1000. What about cos theta? Cos theta this time is going to be next over, adjacent over hypotenuse. So it's going to be 4 over 5. So when you multiply this, you're going to get 800 Newton, our answer. Okay? So the answer of number 3 will be F horizontal 600 Newton and F vertical 800 Newton. Okay? This is going to be the answer. Any questions? You guys have? All right, let's move on. Let's do the question here and then we can go back to the other questions, okay? So let's move on. So the other questions that you guys need to do, question number 5, okay? So number 5, you have a uniform plank over here. It is supported by 2 equal 120 Newton forces at X and at Y. So here it's 120, here it's 120 Newton. The support at X is then moved to the Z. So we're going to move the support from X to the Z, half weighted to the plank center. So that means the half of the plank is over here, okay? This is half of the plank, okay? So half of the plank, if we have 2 forces over here, 120 Newton here, and 120 Newton over here, that means we have at the center 240 Newton, okay? So at the center we have 240 Newton force. Don't forget this is our center. Let's call it L. So let's first of all use Y as pivot, okay? Y as pivot. If you use Y as pivot, what's going to happen? Now we can find the Z here. How can we find the Z? We're going to just multiply Fz times, what is the distance from Z to Y? There is going to be, like, here is, let's call here is 1 meter, okay? When you call from X to Y 1 meter, so since you moved like quarter from X to Z, the distance is going to be 3 over 4, okay? So it's going to be 3 over 4 L. Let's call it L, okay? 3 over 4 L plus what we have here 200 Newton over here, 240 Newton times, since it is middle point, L over 2 equal to what? It's going to be equal to 0, okay? Since we consider Y as pivot, the torque will be 0, okay? So here, when you do the calculation, you're going to see that Fz will be negative 80 Newton, okay? Negative 160 Newton. I just did that calculation. So negative 160 Newton. This is going to be the value of Z. What does this mean? This means it is upward, okay? Since it's in negative, the direction of the Z is upward, okay? So we are going to take this, we are going to, since we are looking for torque, we are going, at the end, we are going to ignore the negativity over there, okay? So let's now find the for Y. So what's going to happen? Now we are going to, we know our Z. So to find the Y, we are going to use this formula, Fy plus Fz plus 140 equal to 0, right? When you add all of them, you're going to get 0. So Fy then plus, we found negative 160 Newton, our Z plus 240 Newton equal to 0. Negative 160 plus 240 is going to be positive 80, right? Equal to 0. And then we are going to find our Y again, negative 80 Newton. So that means again it is upward. So if you want to write their magnitude, you are going to write like this. Fz equal to 160 Newton and Fy equal to 80 Newton. That is going to be your answer. Okay? Any questions you guys have? All right, if you don't have it, let's move on. Let's continue. So next we have question number 7. This question actually is easy. I think you guys already did it, but let's do it again. Since the system is in equilibrium, what are you going to do? You're going to multiply this part and you're going to equal to this part to find the m. So what's going to happen? So m times 0.5. Again, you have to convert centimeters over here into meter, okay, in order to do the calculation properly. 8 times 0.2. Okay, so when you do this, you're gonna find the m. 8 times 0.2 over 0.5. So 8 times 0.2. Again, since both of them has one what do you call it? One decimal number. They're gonna simplify themselves. So it's going to be 16 over 5, which is gonna be 3.2. They're going to find 3.2 kg over m. Okay, so the answer for m will be 3.2 kg. If m is located 50 centimeters away from the pivot, it has to be 3.2 kilogram in order to satisfy the equation. Okay. All right. Next. Next we have question number 15. Okay. So question number 15 is going to come up next. Let's go to the 15. Question number 15. Let me just draw it. Sorry, I couldn't take it over here. Let me just give me a second to let me to draw it. Number 15. Number 15. Okay. All right. So number 15 here. Let's do it like this. So here's 37 degrees. You have over here T, right? And you have a force of 12 Newton over here, right? And okay, these are the given. These are the what is given us. So here, let's just again divide our given into its components, like into its vectors. So again, here we're gonna have a weight, right? So let's draw the components from this side. So what's going to happen? Again, since here is 37 degrees, this part also is going to be 37 degrees, right? And let's make it like right there over here. Sorry for drawing. Fine. So let's draw it properly. Okay. So now what's going to happen? So remember the first condition of equilibrium, the total F will be 0, right? So the total F will be Fx will be 0. So to find the Fx, what are we going to do? What is Fx over here? What is the horizontal component? 12 over here, right? There is 12, and here we are going to find T. Let's first find the T actually. To find the T, we are going to do like this. Sine 37 equal to, how do you find 37? T over like hypotenuse over T, right? Hypotenuse over T will give us, let's say this hypotenuse over T, that is going to give us T. Okay, so let's crisscross it. So T will be what? T will be sine 37, like sine 37 times T will be O. So sine 37 times T equal to O. Okay. And the second part for the horizontal one, we're gonna get the T as cos 37 times T equal. Oh, this is horizontal component, okay? This is horizontal, this is vertical. So again, for the horizontal component, what we have for T? So horizontal component is here, okay? So here we have T times cos 37, and here we have T times sine 37, okay? So for the horizontal component here, we have 12 Newton, right? Let's take this direction as positive. This direction will be negative. So 12 Newton minus T times cos 37 equal to 0. Okay? So now let's apply this to for the y component, okay? That is also going to be 0. So what about y component? Let's take upwards as positive and downward as negative. Okay, so that means it's going to be like this: t times sine 37 minus weight equal to 0. Okay, so now we can easily find t over here. Let's use the first equation to find the t. Okay, so when we use the first equation to find the t, 12 minus t times, what is the value of cos 37? That is 0.8, right? Equal to 0. Okay, so to get the t over here, we're going to use t equal 112 over 0.8, right? So let's multiply here by 10 and here by 10 to make them whole numbers. So it's going to be 120 over 8. And then T will be 50 Newton. That is going to be the value of T. Okay? If you want to, this question is asking the tension force, so that's how you find the T as 50 Newton. But if you are asked to find omega over here, so you can just put T over here, like 15 times, right? Find 15. Sine 37 is 0.6 minus omega equal to 0. When you send the omega over here, or W over that, you're going to multiply it, and you're going to find weight as 9 Newton. Okay? But the question is asking you tension force, so this is going to be the answer. Okay, tension force is 15 Newton. Any questions you guys have? Okay, let's move on. Let's move to number 18. So number 18, you have this figure. It's asking you a uniform bar of length 2 meter and 30 kilogram is supported by two less ropes which are attached to a fixed horizontal bar as shown in the figure 5. So what are the tensions in each rope when 700 Newton weight is suspended at a distance of 0.5 meter from the left side of the bar? So if here is 0.5, that means you have 1.5 meter from T to A, okay? So here, what we have to do, what we are going to do actually. So first of all, let's say the torque on the left is 0, okay? First one, the torque on the left is 0. See if the torque on the left is 0, we can find the T2 here, okay? We can apply here a weight times D, okay? Weight times D plus mg, right? There is going to be mg over here, don't forget it. Mg times L over 2, length of the bar divided by 2, which is going to be 1 meter, equal to 2 times y2, because we are taking from T2. So from T2 to T1, it is 2 meter, right? So 2 times T2, okay? So when we do this, let's put it here, our value of the V, which is 700 Newton, times 0.5, plus, what is our value of the M? 30. Let's say gravity as 10, and 2 over 2, because the bar is 2 meter, equal to 2 T2, okay? So when we do this, 700 times 0.5, it is going to be 350, right? Plus 300 equal to 2 T2, okay? So it's going to be 650 equal to 2 T2. When we divide both parts by 2, you're going to get T2 as what? 325 Newton. This is the value of T2. This is what we consider as we consider the left part of the rigid bar is 0. The torque is 0. Now for T1, this time we are going to consider the right part. Okay, the right part is 0. So that means what's going to happen? Now let's consider for second one the torque on the right, now is 0. Okay, the torque on the right is 0 now. So let me change the color. So if the torque on the right is 0, that means we are going to take from weight to T2. Okay, from weight to T2. So it's going to be 1.5 times weight, which is 700. Okay, plus again 300 times 1 mg L over 2. Here, what's going to change? Here again, from T1 to T2, how many meters we have? From T1 to T2, we have 2 T2, okay? T1, 2 T1, sorry. This time again, it's going to be 2 T1 because the distance from T1 to T2, it is 2 meters, okay? So let's do it again. 1.5 times 700, it's going to be 1050 plus 300 equal to 2 T1, okay? So it's going to be 1350 equal to 2 T1. Again, let's divide them into 2. When you divide them into 2, what's going to happen? The T1, the value of the T1 is going to be 765 Newton, okay? 765 Newton will be the answer for T1. So T1 is 765 Newton and T2 is 325 Newton. That is going to be your answer, okay? T1, 675 Newton, and T2 is going to be 325 Newton. That is your answer, okay? Any questions so far? Yep, okay. So then let's move to number 19. Number 19 was hard, I think. You guys have difficulty of number 19. So let's do it together. Number 19. So number 19 is asking you a 10-meter uniform ladder weighs 200 Newton rest against a frictionless wall. The ladder makes 53 degrees angle with the horizontal, okay? If the ladder is just on the verge of slipping, that means it's going to about to slip. When a 600 Newton firefighter is 6 meters long, the ladder from the bottom, what is the coefficient of static friction between the ladder and the ground? Okay, so let's first draw our ladder. This is going to be our wall, okay? This is our wall. And we have ground over here. This is ground. And here we have our ladder, okay? This is the ladder. The ladder and ground makes a 53 degrees angle, okay? So first of all, let's define the forces on the ladder, okay? So what force we have? First of all, we have a force over here due to wall, okay? Force due to wall. Here we have a force due to ground, okay? Force due to ground. We have here normal force, and here in this direction we are going to have friction force, okay? And here what we have, this is the distance of ladder, let's call it L, and here we are going to have at the center mg, the center of mass for what? For ladder. And here we have the height of the wall, okay, which is 6 meters. So first of all, let's find the horizontal component, okay? What are the things that represent our horizontal component here? We have force due to wall, and we have force because of the static friction. So force due to wall minus force due to friction will be equal to 0. This is our first equation, okay? The second one, let's find the horizontal component. Again, the total of the, again, let's write over here, fx will be 0. And the total of the fy, again, it will be 0. So let's find them. So let's consider again the upper part, the up direction as positive, the down direction will be negative. So what we have for the horizontal component, we have force due to ground, our normal force, and our weight, the ladder's weight, okay? So it's going to be like this, Fg minus Fn minus Fmg, let's call it mg, equal to 0, okay? This is going to be our second equation. But here we can find the force due to ground easily. Why? Because we know that the normal force is 600 Newton, right? And our weight over here is given you as 200 Newton. So we can find Fg as 800 Newton, okay? So let's apply the second condition of equilibrium over here. What was the second condition? Do you guys remember? Second condition tell us the torque will be 0, okay? The torque will be 0. The torque acts on the ladder will be 0. the second condition. So let's apply second condition. Second condition of equilibrium, okay? So let me change the color for you guys. Let me get the blue. So then what's going to happen? Let's find here F wall times sine 53, sorry, sine 53 times what is the length of ladder? What is the length of ladder? It's giving you 10 meter, right? Equal to 200 times, what is 200? Weight times, okay? Weight times, weight times L over 2 times cos 53, okay? This is the equation that we are going to use for to get the what is it? Okay. And it's going to be, yes, where?
Is it the first equation? Is this the first equation?
The first equation over here. No, that was because of the force, but here what we are doing is we are applying the torque here, okay? We are applying torque.
Torque. Okay.
Second condition, yes. We are applying torque over here. So,
okay. Okay. What does W stands for, Mister?
W stands
W
for
times
weight.
L over 2.
It stands for weight, okay? Weight times L over 2. Plus actually weight. Plus, yeah, weight. Okay. Just a second. I did a mistake over here. Just give me a second. Okay. So then the plus, it is going to be plus, let me just write over here. Plus this time normal force times the ladder's height times cos 53, okay? Okay, when we apply the torque over here, again, the vertical one is going to be equal to the horizontal one, okay? So let's do it. So 10 times 0.8, right? The cos sine 53 0.8 equal to what is our W? We are living alone, by the way. Okay, let's go ahead. 10 okay. Okay. So our W is 200 times, what is our L? The L is 10 meters, is giving you, right? It's giving you 10 meters, so L over 2 means 5, right? Times our cos 53, wait, we are running out of time, sorry. 0.6 plus 600 times 6 times 0.6, okay? Okay, did I forget something?
Okay.
No. Okay, so let's do it. So here, when we do this equation, we are going to see that here, we have FW, sorry. So we are going to get FW when you do this equation. After that, we are going to find 345 Newton, okay? When you do this all, we are going to find our force due to volt is going to be 345 Newton. So let's go to the first equation now. Okay, so F volt equal to Fs, right? From first equation. Okay, so yes. We find F volt 345 equal to F normal times, we find F normal, F ground actually. F ground times, what is it? It's going to be mu. What did you find F ground due to ground? F 800 Newton, right? So let's put it here. It's going to be like, when we find the mu, it's going to be 800, no, 345. Just a second. Sorry, guys. We'll get too crowded. So it is going to be 345 over 800, right? So when you divide this, you're going to get around 0.43, okay? So the mu will be around 0.43, okay? Around 0.43. Yes.
What does F ground stands for?
F ground stands for the force due to ground, okay? The force due to ground.
Due to the ground?
Yes. The force due to ground. It's going to be a combination of normal force and mg. Okay, both of them are going to give us
mg.
yes
Weight.
mg due
Weight
to
and
weight
normal
and
force.
yeah, normal force will give us the force due to ground. Okay, and that is going to cause the
Isn't it the same,
friction.
sir?
No, they are not the same.
Isn't
They are
it the
not the
same,
same.
sir?
They are not the same.
I mean, like
No, they are not the same.
the normal force and the weight.
No, normal force, the weight are not the same. Look, weight is due to ladder, okay? This is the weight of the
Okay,
ladder.
since it's inclined.
Yes, it is weight of the
Okay.
ladder, okay? And the normal force is like
Okay.
just vertical,
Surface
okay?
force.
Yes, it's just vertical.
Okay.
All right. Okay, any questions? This is number 19. We just have a few minutes.
Yes.
We have 7 minutes actually. Okay, let's do number 22. Number 20, let me show with number 22. We have time, I think, for that. I'm gonna share this so you can check it out later as well. Okay. If you have any questions, you can ask me.
Okay.
So let's go to number 20. Let me take my color for number 20. Oh, number 20 is here. A ladder of length 3 meter and mass 20 kilogram. Okay, you're gonna apply basically the same thing, but here there is only one difference. You don't need to deal with the friction force. Okay, you don't need to deal with the friction force, so it's going to be easier than previous question. Okay, so a ladder of length 3 meters. So let's first of all draw what we have here. The ladder we have, which is 3 meter. Okay, ladder 3 meter. Okay, the distance of the length of the ladder. Vertical angle between the wall and the ladder is 30 degrees. So vertical angle here is going to be 30 degrees. Okay, since vertical angle between the wall and the ladder. Okay, so here is 30, here is 90, right? And here is going to be 60. Okay, so so it's asking you what is the magnitude of normal force of the contact point on the wall. We are going to call the force due to wall and B, okay? And at the contact point on the ground, it says NG. So it's going to be NG. Here is going to be NG, okay? Like you find the FG, we are going to find the NG over here. Again, we have the weight of the ladder over here, which is mg, okay? So now we can find it easily. So the total force, the first condition of equilibrium will be 0, right? So then what's going to happen? Fg minus mg, like ng minus mg, right? It's going to be 0, okay? This ng, okay, ng, like G is not the G that we know, okay? The G represents the ground, okay? The force due to ground, okay? Let's call it ng. Since he's asking over here ng, okay? So then let's put it here. Ft ng is going to be equal to mg, right? So our m is given us 20 kilogram times what is the value of G? 10. When you multiply them, you're going to get 200 Newton. This is going to be the value of the Ng. So from second condition, this time the total torque will be 0. Okay? So the total torque will be 0, so it's going to be like this. Nw times L times sine 60 equal to mg times L over 2 times cos 60. Okay? So the horizontal component is going to be equal to the vertical component. Okay? So we can find NV over here now. So NV times NW actually times what is our L? It is 3 meter times what is the value of sine 60? Do you guys know? 0.86, I think. I just remember. It was something like that. So M is again 200 times the half of the L is 1.5 times 0.5. Okay? So when you do this, at the end, you're going to get the force due to wall as 57.7 Newton. Okay? The force due to wall is going to be 57.7 Newton. And the force due to ground is going to be 200 Newton. Okay? These are going to be your answer. Ng is 200 and W 57.7 Newton. Okay? Any questions? Do you guys have? Oh, Ooh, okay. All right, guys, I'm stopping here.